Hi, this is John Bach, President of Puget Systems. In this video, we'll be taking a look at using SSDs, specifically Intel Optane SSDs, to accelerate network-attached storage, in this case with the platform FreeNAS. Now, we do a lot of testing on the workstations that we build here, and every time we test one of these workstations, we have to copy over dozens of gigabytes of benchmark tools and utilities and software, and that's on every single PC that goes through our production line. So that's a lot of data to move around, and we use network-attached storage for this, and that's in a server in our server room that we put in place years ago. But it's been there a few years, and it's time we give that system a shot in the arm. We want to speed it up. We want to be more efficient with those tools. So recently, we wired up all of our install stations where we image our operating systems and do all of our testing. We ran 10 gig network lines, 4 of them, to these installation benches. And then we give a 10 gig line to every PC that's out there on those benches. But of course, all of the networking speed is only good if our storage server can keep up, if it can actually serve out the data that quickly. So today, I will be looking at accelerating that network-attached storage, that FreeNAS server, with SSDs. So we use the FreeNAS platform for our storage here. And in the process of accelerating it with SSDs, I learned a lot. Now, the first thing we need to do is benchmark our server before we even make any changes, so we know what our baseline is. So if we look at the storage array that we have now, we have 4 Western Digital RE 4 terabyte drives. Those are just platter drives. They're enterprise class. They're good drives, but they are platter drives. So as I copy the files from the server to my local machine, I'm going to be showing you 4 things. On the bottom left is just the network speeds that I'm monitoring on my machine. See how much throughput I'm putting through the network. On the bottom right, I'm actually showing you stats from our server. I'll be focusing actually on the CIFS stats to monitor the cache population. That'll be more important later. The top right, I'm actually showing a real-time view of the read and writes from the data volume, so we can actually see how much data is actually being pulled from the platter drives themselves. And then the top left is the actual file copies being done. So we've started it now. This is pulling large ISO files, Linux install disks from the server. And as that copy starts, you can see that there is quite a bit of data being read from the platter drives themselves. If we look at the Ethernet speed, I'm pulling in, a gigabit. I'll be pulling in 2 gigabits, even 3 gigabits sometimes. And that's about what we would expect from a server like this. We have 4 platter drives in there. Each one can do about 150 megabytes a second. You do the math, and we're pulling the speeds that I would expect to be pulling off all 4 platter drives. So as this test runs, I'll go ahead and speed things up so we don't have to watch paint dry here. But the end result is, after I copy 57 gigs of data off of our server, I average about 2 gigabit in speed. So about 1/5 of what our network connection can do. And no matter how many times I run this test over and over and over again, I'll be getting the exact same speeds of 2 gigabit. But we just installed a 10 gig network, so that's not fast enough. So next up, let's put in a SATA SSD as cache and see how much faster we can make things. So to do that, we go into our volume manager. We select the storage volume that we want to augment here. I'm selecting my 1 terabyte SSD, adding it as an L2 ARC cache, and we'll wait for that to be added to our array. So the way that this works, now that we have an SSD cache to our array, is every time we read data, it also loads that data onto the SSD, so that if in the future we request that same data again, it's already cached on the SSD. It can load from that, and it doesn't have to go to the slower platter drives to reload it again. So that's perfect for us, because what we're doing is we're copying the same data over and over and over again for every PC that goes through our production line. So caching to an SSD should be a really great help for us. It should be a good boost in performance. So as I start this test again, you'll see that on the first run, I'm getting pretty much identical results. I'm pulling 2, 3 gigabit average, just as before, and that should be what we expect. Nothing's been loaded on the SSD yet, nothing's in the cache, so it's pulling from the platter drives just like before. But this time as we go along, keep an eye on the bottom right-hand panel. You see 2 boxes, the ARC size and the ARC hit ratio. Now what that is, the ARC is our cache, and there's 2 different types. There's the blue dot, that's the ARC. That's always there in FreeNAS. That's your system memory. That's cache that's very, very fast, but we also don't have very much of it. I have 24 gigs of memory in this server. The L2 ARC, the red dot, that's what we just added. That's our 1 terabyte SATA SSD. Much, much larger. And what we want to see is we want to see the ARC and the L2 ARC fill up with all this data that we're putting into the cache. Now down below, the ARC hit ratio, that's keeping track of how often when I request data is it actually coming from the cache. Or if it's not coming from the cache, it has to load from the slower platter drives. So we want to see a higher ARC hit ratio. We want to see 100% of our data coming through either the ARC or the L2 ARC, ideally. That would be the perfect scenario. As I fast forward through this first pass and look at the second pass, you can see that our cache is starting to populate. That red line is growing as our L2 ARC is being populated, but it's still not very exciting, not a lot of changes, so let's keep fast forwarding and go through another pass and another pass. And as we go through, the cache is holding more and more of the data, and you start to see our hit rate is climbing. So more of our data is actually being pulled from the cache. And down in the bottom left, you'll see that our speed is also improving. We've already almost doubled our speed. Now we're approaching 4 gigabit. And then after that, no matter how many more passes I fast forward through here, we're still holding at about that same speed. Well, it makes sense. Again, how fast is this SATA SSD that we're caching to? Well, it's a SATA SSD. It's rated for about a little over 500 megabytes a second in read. You multiply that by 8 and you get 4 gigabit. That's exactly the speed that we're seeing. So we're successfully caching to that SATA SSD, but the speed limitation on that SATA SSD just isn't going to cut it. We want 10 gigabit, not 4 gigabit, so we have to keep working. So let's turn to a drive that I think would be perfect for this job. Intel just launched their new Optane drive, the 900P. I have a 480 gigabyte drive, then I'll add that to our volume as an L2 ARC cache. And I think that it's going to work really well for this. We could get the same throughput with a lot of different NAND-based NVMe drives out there on the market, but there's 3 things that draw me to this Optane drive specifically. First of all, it has much faster write speeds than a lot of the drives that you'll find out there that are based on NAND. So with a faster write speed, I can populate the cache a lot faster. Second, it has a lot more consistent performance over time and consistent performance at low queue depths. That's something that I think would be pretty ideal for a cache drive. And then third, it has excellent endurance. As an Optane drive, I believe it's 10 drive writes per day that it's rated for. Don't quote me on that. But in any case, it's higher endurance than you'll find with the NAND drives, which is something I really would like in a cache-based solution. This isn't quite at a level where I need to go to enterprise class drives, but endurance is something I care about, so that's a good fit for me. Now, as I fast forward through the file copies over and over again, you'll see that we are populating our ARC cache, our L2 ARC cache, and our ARC hit ratio is getting better. And if you look at our Ethernet speeds in the bottom left, they are improving over time, but I'm having to really fast forward through this and copy over and over again. I had to copy the files about 10 times before the cache was fully populated. And even then, I was expecting a little more speed than this. We're only pulling about 6 gigabit on average. So it's time to investigate a little bit. Now the problem is that in FreeNAS, or even just the CIFS file system in general, the default settings for the L2 ARC weren't made for something as fast as this Intel Optane drive. By default, it only allows 8 to 16 megabytes per second of data to go into the cache, and with a number that low, it made sense that we had to load the data over and over again, and it took a very long time to populate that cache. So there's 3 settings that are important to change for a setup like this. The first is the L2 ARC write max. Now that refers to how much data per second can be written into the cache. The default is 8 megabytes a second. In my case, I upped it as high as 400 megabytes per second, so much, much higher. Now the key is you need to know your drive. You need to know your cache drive, and you don't want to write so much data to it that it'll slow down your read speeds, because the read speeds is what's really important here. That's serving data out to the clients. So you need to make sure you choose a number that you know your cache drive can maintain. I did a bunch of testing with my Intel Optane drive, and I found that 400 megabytes per second it could sustain very easily. For other drives out there, that might be way too high. Next up is the L2 ARC write boost. So this refers to when your cache is cold, when there's no data in your cache drive yet. How much more do you want to allow to be written to your cache drive per second? In my case, I upped it again from 8 megabytes per second up to 400 megabytes per second. This Intel drive can sustain over 1,000 megabytes per second write to it, so that wasn't any problem. But again, you need to know your cache drive and know what it's capable of to know what number you can put in there. Last up is the L2ARC no prefetch. You need to set that to 0 if you're in a workload like us. We do a lot of sequential writes, a lot of large file copies, and that is exactly what we want to have in the cache. For other people, having a cache drive might be less about the speed of the transfers and more about freeing up operations per second for other things that your storage server is being used for. So really, your mileage will vary. You need to know your own workload to know what setting is right for you. So after you put these 3 settings in place, you do need to reboot your server for them to take effect. And with that in place, let's go ahead and start up the file copies again and see what we see. I'm going to fast forward to the second pass, and you see that even after just 1 pass now, the cache is filling up much more quickly. By even the second pass, I'm already faster than I was after 10 passes with my previous settings. And now if I fast forward a little more, by our third pass, I'm already pulling 8, even close to 9 gigabits. And if you look at the top right, showing my reads and writes from the platter drives, it's down to really small amounts, or even 0 now. So that's great. That means that I'm pulling all of my data from the cache at this point. I've maxed out pretty much everything I can do here, and I'm happy. I'm still not using up all of my 10 gig network, but really, in order to get all the way up to pretty close to that 10 gig, there's a lot more tuning that has to be done. TCP window sizes and buffers and jumbo frames, things that have to be done both on the server and the client, and I can't really do that because this is going to be data that's copied to customer machines, every single one that goes to the production line, and we're not going to tune to our specific network every single customer machine. So I'm really happy with this. I'm really happy with getting close to 9 gigabit on our 10 gigabit network. So this is great. I really enjoyed this process. I really enjoyed learning what it takes to get all this speed of a FreeNAS server. I'm actually going to be doing a follow-up video on all the different possible bottlenecks that can go into a 10 gig network, because I sure learned a lot in this process. I'm by no means a seasoned expert in network tuning, so if you see things in this video that you would have done differently or things that you would have recommended for me, leave it in a comment. I'd be happy to check it out and learn from your experience.